Hello friends. Now that we have a basic understanding of the Black-Scholes model, let us try to implement it. And if you remember from the last lecture video, there are 5 parameters that are key to pricing an option. They are number 1, the current price of the underlying asset or stock, and that information is observable from the market, so that's not a problem. Second, we need the strike price. Again, if you are pricing an option, you know what is the strike price of that option. And therefore, the second parameter is also market observable. The third parameter was time to expiry. Once again, if you're pricing an option, you already have the key information about the option contract, and that includes time to expiry as well. And therefore, this third parameter is also market observable. Fourth is the interest rate. This parameter can be a bit tricky, but many people also consider it as a readily available market parameter because we typically take the interest rate on the long-term government bonds. So we can take whatever is the yield for the 30-year US government debt as the interest rate. And then finally, the fifth parameter, which is the most critical parameter for option pricing, and that is volatility. Now, how do we define volatility? When we talk about volatility of an asset, we generally refer to the standard deviation of the annualized return of that particular asset. And if you have to calculate historical volatility, you will definitely need historical data. So the first thing that I'm going to do in this code is use the same historical data code that we have been using and extract historical data for a number of tickers. So let's again extract data for Facebook, Amazon, and Intel. I want to extract daily data. You can extract candles of other granularity as well, but just make sure that when you are annualizing it, you are using the right multiplier. But right now I don't want to get into all that, so I'll extract 1 day candles going back 300 days. And then once I extract this data, I am converting it into data frame. So this is something that we have done a number of times, so I don't really think we should have any problem with this. So let me run this code and extract the historical data in a data frame. You can see that data was successfully extracted, and we have been able to store the data in a dictionary where each key is the ticker that we are interested in, and the corresponding value is the data frame having daily candles. Now, finding historical volatility is fairly straightforward, and I'm pretty sure that we have calculated volatility in my other interactive broker courses, because without that, we can't calculate the KPIs like Sharpe, etc. But let me revisit that, because you will see in the next lecture video that there is a very important distinction in the volatilities that we are calculating. So right now we are calculating historical volatility. So let us do that. So all that I need to do is iterate through each of these tickers in the historical data frame. So for ticker in historical data, now I want to access each of the data frames. So historical data ticker, and then I want to access the columns having the close price. And why do I want to access it? Because I want to calculate the daily return. So once you have the column having the close prices, all that you will need to do is use the pandas extremely popular and very helpful function pct underscore change. If you recall, pct underscore change calculates the percentage change for any column. So all that it will do is that it will take the close price and calculate its return based on the previous row's close price, and it will do the same operation for every single row. So in a sense, we are calculating every period's return. And let me store this information in a column called return. So now that we have the column with daily returns, calculating volatility is a child's play. All that we'll have to do is apply the standard deviation function on the return column, and this will give us the volatility. But are we forgetting something? We are forgetting to annualize this volatility. This is an important concept, so let me show this using a dummy variable so that you have a better understanding. So let me create a data frame, and then let us store Facebook's historical data in data frame. So let us copy this into this df variable. Okay, so we have a data frame having Facebook's daily information. Next step is to calculate the return. So let me copy this and paste it here. Instead of historical data, this would be df, And thanks to this example that I'm working on, I figured out a typo here. So I have missed the key for that particular dictionary that we are working on. So let me fix that as well, because we'll have to access every single data frame and we can only do that if we are using the key. So here, if I'll run this command, you can see that we have got a return column and these are daily returns. And now if you apply standard deviation function on this return column, you will get the standard deviation of daily returns, which is not something that you are interested in. So this is telling you that the daily return of Facebook has a standard deviation of 1.95%. But we have seen in the last lecture video that for Black-Scholes model, when we talk about volatility, we mean annualized volatility. So we'll have to convert this into annualized volatility, and we do that by multiplying the daily volatility with root 252 because there are 252 trading days in a calendar year. And once again, if you're using a different candle, this multiplier will change. And we have discussed that previously, so make sure that you are careful about that. So all that we'll have to do is multiply this number with the square root of 252. So let us use numpy's square t function. I don't think I have imported numpy, so let me do that as well. Import numpy as np. Let us run this import command. And now if I'll run this line of code, we'll get the annualized historical volatility of Facebook. And this is the number that we can pass in our Black-Scholes model. Okay, so let me delete all this information. And here also, let me multiply this with np.squaret 252. So now we have got the annualized historical volatility. But where are we storing this information? Right now, we don't have any data structure where we are storing the volatility. So why don't we create a empty dictionary? Actually, let me name it historical volatility or something like that, because this is historical volatility that we are calculating. And in the subsequent lecture videos, you will see that historical volatility doesn't really work in option pricing, but that's for a later lecture video. Right now, store this information in a blank dictionary and let us call it historical volatility. So here I will have to call this variable and then assign it to whatever ticker that we are working on. All right, so this should store the annualized volatility for each ticker. So let me run these 4 lines of code and let's see what happens. And you can see that we have got the historical volatility dictionary updated and it is giving us the annualized volatility of each of the tickers. So Facebook is 33.27. Interesting. We got 31.08 here. What happened? Okay, so that's Intel's annualized volatility. Let me see what I did. Just give me 1 second. Let us go back to the code that we ran. Okay, why did we get Intel's historical volatility here? Oh, sorry. So when calculating the return, I use the ticker and the variable that is stored in ticker is actually INTC. So although we created a data frame and stored Facebook's data on it, we actually used historical data ticker, which is Intel's close price, and calculated the change on that. And that's the reason the volatility that we calculated was actually Intel's and not Facebook. So that was shoddy on my part, so sorry about that. So all I wanted to explain is how we can convert daily volatility in annualized volatility, and that's what we did. Okay, so let me get back to where we were. So this code helped us calculate the historical volatility for each of the ticker that we are interested in. So now we have all the information that we need. So in the next lecture video, we will implement the Black-Scholes option pricing function using all the 5 parameters that are required to price options. So I'll see you in the next lecture video. Thanks a lot.